pray for an atmosphere of understanding and clarity, even in the name of Jesus. I decree and declare that today's program shall be a success. In Jesus' name we pray with thanksgiving. And all shall say amen.
A very big amen to this powerful prayer. We have a special mother in our midst, which we can't do without. And for the first time in our 45 years as an institute, we have the first female director. I call her our quality director. She's the first lady who has led us to get the ISO accreditation for some of our processes. And shall we invite our own quality director, ISO 9001 2024 accredited quality director, to give us a short word.
Good morning, everyone. The introduction gets, is it worse or better? Innovated. Thank you so much, Helena, for the opportunity once again to speak to staff of Noguchi Memorial Institute for Medical Research on such a wonderful day, a second lecture series. Last week was wonderful, and I know today is going to be super. You know, in the some of you are very young, but in the 1980, we had a new virus circulating, and in 1986 the first was detected in Ghana. Today it's exciting to know that the institute that cultured the first virus is this very institute. Noguchi deserves an applause. So this morning is going to be another impactful day, and we are going to hear how the institute, also based on their work, impacted the Ghanaian population in terms of public health. So I'm not going to be the presenter, but I want to thank Professor George Boatinche, Professor George Boatinche, for agreeing to give us this wonderful experience. Please let us open our eyes and ears as we listen to another impactful story of Noguchi Memorial Institute for Medical Research. Thank you.
Thank you very much, our own quality director. We have, as our chairperson for today, an associate professor of virology in the Department of Virology of the Noguchi Memorial Institute for Medical Research, College of Health Sciences, University of Ghana. He obtained his bachelor's degree in biological sciences from the Kwame Nkrumah University of Science and Technology, Kumasi, in 1994. He has a Master of Science degree in virology in November 2002 and a Doctor of Philosophy in molecular virology in 2008, both from the London School of Hygiene and Tropical Medicine, UK. So this is a true virologist from birth. He is the immediate past head of the Department of Virology and the current head of the WHO Regional Reference Polio Lab at Noguchi Memorial Institute. He is deeply involved in research on human enteroviruses such as polioviruses, echoviruses, Coxsackie viruses, and the numbered enteroviruses. He led the team that genetically characterized all the wild polioviruses that have circulated in Ghana to date. He was part of the team that sequenced and characterized the wild polioviruses used by vaccine manufacturers across the globe to create a database for future reference. Shall we clap? That's a good note to clap. He piloted the detection of polioviruses from the environmental sewage and wastewater in Ghana in 2016, leading to its rollout in 2018. With the emergence of global SARS-CoV-2 pandemic in 2019, He led the coordination of the laboratory testing for COVID-19 response at the Noguchi Memorial Institute for Medical Research. His current research is on wastewater epidemiology, where he focuses on multi-pathogen detection within communities to serve as an early warning system for public health intervention. He is a member of the American Society of Virology, a member of the WHO Afro Polio Consultative Group, a member of the WHO Afro Environmental Surveillance Consultative Group. He also belongs to the National Experts Committee on Polio, a member of the National Task Force on Containment of Polio, a member of the National Certification Committee on Polio. As for this one, you should know who I'm going to introduce. Please help me welcome Professor John Kofi Odum, our chairperson for today. Keep clapping as he comes. Thank you.
Thank you very much. Director of the Noguchi Memorial Institute for Medical Research, Professor Yeboah Menu. Deputy Registrar, Mr. Theodore Ahunu. Senior members and faculty of University of Ghana. Senior staff, friends of the media, ladies and gentlemen. We are going to listen to our second lecture for this October in a series of lectures that will be given. And it's all to support our 45th anniversary. Director has already mentioned that HIV was first or globally detected in 1980. 6 years later, it was also detected in Ghana. I wish Prof. Sampofo was here to tell us more about this particular virus. But talking about HIV research, Ghana has done a lot. Looking at what Ghana is doing, it's an essential part of the country's response to HIV/AIDS epidemics. And if you look at the scope, it covers prevention, it covers epidemiology, covers social sciences, etc. But Noguchi, as Director mentioned, has done a lot in terms of HIV research. If you talk about HIV surveillance and epidemiological research, Noguchi has done a lot. Looking at helping to track the spread of the virus, understanding the epidemiology, provision of data for public health policies, all this area Noguchi has contributed. If you look at even HIV research in terms of populations, like research on sex workers, men who have sex with men, etc. All this research were conducted at Noguchi here. If you come to HIV diagnosis, Noguchi has also contributed a lot to the country. Looking at the validation and then improving diagnostic tools used for the detection of HIV infections, Noguchi has done a lot. Antiretroviral therapy, here too Noguchi has done a lot. If you talk about HIV vaccines, Noguchi has done a lot. Even though for now we still don't have licensed vaccine for HIV, what Noguchi is doing has contributed to scientific knowledge and could also help in breakthrough in future to get the vaccine. You can also talk about HIV co-infections. You can talk about capacity building and training of future scientists. You can talk about community engagement and public health involvement. All these areas Noguchi has contributed. So talking about HIV research, Noguchi has done a lot. This morning, we are going to listen to HIV research and future directions in Ghana. And it's going to be presented by an associate professor of medicine, molecular microbiology, and biology at the Nguchi Memorial Institute for Medical Research, University of Ghana. He's also the founding director of research at the University of Ghana Medical Center and an associate professor at Washington University in St. Louis. He obtained his medical degree from the University of Ghana Medical School. After completing the internship at Kolebu Teaching Hospital in Accra, he worked as a family physician for 3 years at Mana Mission Hospital in Teshi. During this time, he also earned the MPhil degree from the University of Ghana, where he characterized microbacteria causing tuberculosis in HIV and non-HIV infected patients. In 2003, he moved to the United States to pursue a PhD in molecular genetics and microbiology at the University of New Mexico. His research focused on molecular aspects of HIV/TB interactions in macrophages, and he published a landmark study in the Journal of Cell Biology, demonstrating for the first time that the HIV hijacks the autophagy machinery for viral replication in macrophages. For this work, he received a special mention of distinction in his PhD thesis and was honored by the regents of the University of New Mexico for outstanding scientific achievements in graduate school. Following his PhD, he joined Washington University in St. Louis as part of their prestigious physician scientist training program. At WashU, he completed an internal medicine residency, an infectious disease fellowship, and postdoctoral research in the pathogenesis of HIV. He is board certified by the American Board of Internal Medicine and is a registered consultant physician with the Ghana Medical and Dental Council. In 2016, the American Society for Clinical Investigations honored him with their Young Physician Scientist Award. He returned to the University of Ghana in 2018, where he established the HIV cure research infrastructure studies, also known as HCRIS, to train African scientists in HIV basic science and cure research. His research has been supported by numerous external grants from organizations such as Robert Wood Johnson Foundation, the U.S. National Institute of Health, Expertise Français l'Initiative, the South African National Research Council, and the European and Developing Countries Clinical Trials Partnership, that's the EDCTP. Recent efforts from the laboratory teams have provided important contributions to understanding HIV latency, reactivation, host cell interactions, and perspectives of HIV patterns on the perceived benefits and risks of HIV cure research. For the work on HIV reactivation, he received a patent from the US government titled Inhibition of HIV-1 Latency by isoform selective inhibitions of lysine deacetylase. He is passionate about training and mentoring. He is passionate about training and mentoring the next generation of African scientists. In April 2014, he received special recognition and appreciation from the Center for Gender Studies and Advocacy for his unique and outstanding contribution to mentoring female faculty of the University of Ghana. Recently, he and the colleagues secured an NIH facultative training grant to train 17 Ghanaian scientists in HIV basic science and cure research. He also serves on one of the NIH AIDS grants reserved NIH grant review panel as a chartered member. Ladies and gentlemen, help me welcome Professor George Boatinche. I don't want to wear the lens and Can you help me for my slides to show? Okay.
Yeah, thank you, Prof. Odum, for that long introduction. I want to thank, standing on previous protocols, so all protocols observed. I want to thank the organizers for including me in this very important lecture series. I think if you look at the people on the list, I don't know why I'm part of it, but here I am, so I'll do my best. So for me, working at Noguchi or being part of Noguchi is a dream come true, because I always wanted to work at Noguchi when I was in medical school, so when I was doing my master's, my supervisors, I actually came to Noguchi, talked to somebody in microbiology, in bacteriology. That is how I got my project. And then I was supervised by Prof. Ado and Prof. Mercy Newman at the time. So when I went to my surgeon, definitely came back at the right time, I guess. So I will start by saying some thank yous before I go into the lecture. I want to thank some of the people who have helped me to transition back to Ghana. It's not that easy to be in America for 17 years and then come back to Ghana. So I want to thank those who made it possible. First is Prof. Patrick Ayekumi, our previous provost, who, when I told him about the idea of coming back, was very, very supportive and moved everything he could move to make it possible. And then I came to speak with Prof. Kojo Kuram, who was the director then, and Prof. Ampafu, who was the HOD then, and they were all very supportive, which was really, really, really nice, especially when I told them that, well, I will still be going back and forth to WashU because I feel like what I want to do, I need the help from over there. And they were very supportive. And then, of course, our subsequent directors, including our own director, Prof. Yeboamenu have been extremely supportive in helping me do the work that I will be talking to you about today. And then I want to thank Evelyn Yairaboni for putting up with all of my massive action stuff and helping us to get this program going. And Prof. Kwesiado, who helped my interest in Noguchi in the first place. So I feel like it's always very important to say thank you when you get a big audience like this. All right, so now let's go to the talk. So HIV remains an important public health problem. So far, it has killed almost 50 million people. So that is about the whole of Ghana's population, the whole of Togo's population, the whole of Benin's population, you know. We won't add Nigeria, but Nigeria has too many people. You know, so, and now about 40 million people are living with the virus. And people are still acquiring the virus. You know, last year, 1.3 million people and 630,000 deaths. So it's still a huge issue in the world. And most of these statistics is in Africa. So over 70% of people living with HIV in the world are in Africa. You know, so it is a problem for us, and my strong belief is that we should take the lead in trying to solve it. So Ghana, our statistics is what is shown over there. So we have about 330,000 people, which translates to about 1.7% of the population. And we even have children aged, you know, we have children and adolescents also being part of this number. So it is a problem in Ghana as well. One of the most important things that happened with HIV is that it's probably the only disease that has received intensive research, probably more than any other disease, and also investments. So this is a list of the number of medications that has been approved for HIV alone. You can see that, right? So it's over 50 of them. And about 20 of them are fixed dose combination. That means like they combine different, you know, medications into one pill that a person can take maybe once a day. So starting from the 1980s, when people were dying a lot in the US from AIDS, when, you know, Zidovudin came along, there's been a progressive increase in the number of approvals. Now, if you look at the latest ones, most of the latest ones are combination therapies that have come. So now, really, we do have the tools to, if you like, end the AIDS pandemic, right? Because these medications are very good. And the side effects is minimal, and they are very good in controlling the virus, right? So they can control but not cure. So they can reduce the viral load to what we call undetectable, where if you take a blood from the person and you go to the lab and you do the PCR, the real-time PCR will not detect the virus. Okay, so that is called undetectable. Usually that is the goal for treatment, is to make the patients undetectable. Once they are undetectable, now incontrovertible research has shown that undetectable equals untransmissible. In other words, if somebody has HIV and their virus is undetectable, they cannot transmit the virus even if they have sex, even if they have unprotected sex. Okay, so you can imagine that if we got everybody with HIV on medication, and their virus became undetectable, and they could not transmit the virus to anybody, then the whole epidemic will end. You understand, right? Yeah, so that is the goal, but you know, like any human thing, the ideal usually is not as easy as one imagines. So we do have the medications, we do have the tools. In Ghana, we have the tools as well. The medications we are currently using are actually pretty good. Sometimes there are issues with access. Okay, so I'll get to Ghana's numbers in terms of how we are doing soon. But here is now a little bit dated, but now about 70% of all people in the world who have HIV are on treatment, are on ART, which is not good enough, right? So, I mean, if the medicines are there, why is it not 90%? You know, why is it not 95%? Or why is it not, you may never get to 100%, but why is it not over 90%? And most of the deficiency comes from Africa. So, Ghana, we are far behind in the WHO or UNAIDS 95 target. So here I'm comparing Ghana to Botswana, a country whose population is similar to ours and whose number of HIV patients, so the country whose number of HIV patients is similar to ours. So ours is about 330,000, theirs about 360,000, you know. So those living with HIV who know their status, that is the first 95, we are at 65%. And look at Botswana, right? 97%. Living with HIV who are on ART, that is the second 95. We are at a measly 45. And this is the freshest data from the UNAIDS country data. So, and Botswana, 95. So they have achieved the 95. And people living with HIV who have suppressed viral loads, you know, we are at 40, and they are at 94, right? So we still have a lot of work to do in our country when it comes to controlling the virus. During the question time, maybe somebody will ask why that is the case. then we can speculate. but for now, I'll move on. So what it says is that we still have a lot of work to do in this area. And Noguchi has been at the forefront of responding to the HIV threat in Ghana right from the beginning. As has already been mentioned, the first cases were detected here in 1986. And then, since then, Prof. Ampofo, Dr. Evelyn Bonney, and co. have done a lot of work looking at characterizing HIV-1 and HIV-2. So HIV is not just one virus. So, well, it's one, but it's not one. so there are several variants. Okay, so we have HIV-1, which makes the most of the epidemic. Then there's HIV-2, which exists mainly in West Africa. So we own HIV-2, we in West Africa. It's mainly from like Cameroon all the way to Senegal. That is where it exists. And if you see HIV-2 in any part of the world, it came from those people who have connections to West Africa. Okay, so that is our virus. That one is mild. It's milder. People can have it for over 10, 15 years before they develop AIDS. Unlike HIV-1, where usually about 5 years, a lot of people are developing AIDS. But Noguchi has done tons of work. Most of the work done in the world on HIV-2, a lot of it came from Noguchi. And we do have HIV-1 and 2 combination. There are people who have acquired both viruses, right? So they have the HIV-1 and then they were not satisfied, they got HIV-2 in addition. You know, so those people are also here in Ghana and around West Africa. Noguchi did a lot of work in subtyping the HIV. So we have different subtypes. And this is important because now most of my talk is going to be on HIV cure research. But the HIV has different subtypes. So the one in Europe and US, we have what we call the subtype B. And then in Southern Africa, we have subtype C, and then in Eastern, we have subtype D and B. And then when you come to West Africa, that is where it's more interesting. So we have like a variety of subtypes. And it's not just one subtype, it's like subtype A combined with subtype G, and another subtype combined with another subtype. So we have hybrid subtypes, a variety of a variety of hybrid subtypes. Now, this is very important because what has happened is that a lot of the research trying to find a cure, right, has concentrated on the subtype B. And the tools that have been developed to measure the virus so that we can get rid of it are all done for subtype B. So now, if there's an HIV cure trial right now, and a lot of it is happening in the world, we in West Africa cannot take part because our subtypes do not, we don't have the tools to measure the reservoir for those subtypes. The subtypes are more complicated. Unlike the simple ones like B and the rest, these ones are more complicated. So we are the ones who can work on it, and that is what we are currently doing. Noguchi has done a lot of work on co-infections with HTLV, HBV, syphilis, HCV, and then one of the most important things that is done here at Noguchi is doing resistant testing for the National AIDS Control Program. Now, let me tell you a little bit, at least I have a lot of time today so I can do more explanations. But one of the things when it comes to HIV, I am an infectious disease physician, and I worked as an ID physician in the US for a while, a long time, seeing HIV patients, right? Over there, when a patient comes in, being diagnosed with HIV, we take blood, we send it to the lab, and then we do genotyping of the virus to determine which of the numerous ARTs, antiretroviral therapies, is good for that virus, and then we tailor the medication. Now over here, we don't do that. The excuse is that we are limited resource country, a limited resource region. I prefer to call us, instead of resource limited, I prefer to call us resource mismanaged. So anyway, because of that, patients have to go, they take the medication, they will spend about a year or two before we detect that, they are not improving. Then we come to do the resistant testing. And we even don't have the facilities in the other labs to do it. Only Noguchi can do that in this country. So they send the samples to Dr. Bonnie, and then, we do it for them. So Noguchi plays that very important role where we are able to detect the resistant viruses and let the national program know so that they can change medications for these patients. There have been work done on immunology, and then fellows from Noguchi have, over the years, served on the National AIDS Control Program advisory committees. So that is a lot that without Noguchi, I think the response in Ghana will be much, 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 much worse. So we have done a lot to help the country in this regard. Over the past few years, we have kind of pivoted to HIV cure research because, as you can see, the medicines are there, but the progress is not that much, right? If you could get a cure, then case closed, right? But HIV is not that easy to cure, unlike, malaria or other infectious diseases. As an ID doctor, usually what I want to do is to cure my patients. You come with pneumonia, I give you the right antibiotics, you are cured, you are gone, right? But HIV is not like that. So we can only control the virus, but not cure it at the moment. So why do we need an HIV cure in the first place? First is that although we have all the medications, we are still not able to get everybody on these medications. You know, there are issues of access, issues of economy. You know, for Ghana and most of our resource-limited countries, the medications are not even bought by our governments. Okay, so the medications are paid for mostly by the U.S. government through their PEPFAR program. And recently, I'm sure most of you heard that medication were spending months in the port, and we wanted to charge duty for it. Okay. And here we have medicine. You want to charge? You want to charge duty on that too. Okay, so things like that, you know, all those issues feed into the system, and it makes it difficult to control the epidemic in Ghana. ART is not, you know, water, right? There are toxicities that patients still face. Patients still have to take medicines every day. That may soon change. Right now, the simplest form in Ghana is that you take one pill once a day. That one pill contains 3 or 4 medications, but you take one pill once a day, which somebody may argue, well, most people take one pill once a day, or a few pills once a day, or a few pills a few times a day. So what is the big deal, right? If you have hypertension, you probably take 2 or 3 pills a day. You know, so if you have diabetes, you may take a few pills, maybe get insulin injection or something. So, you know, but there are still toxicities. But the big issue is the stigma, right? So in our part of the world, stigma is still an important thing, where people who are living with HIV are stigmatized. Of course, resistance is a problem, and then access to ART is a problem. So because of all of these, we believe that in our next phase of research at Noguchi, we should focus on cure research. So if a patient comes to the clinic, their viral load is very high. If we give them the ART, usually within 2 weeks, the viral load plummets, and it can remain undetectable so long as they are taking their medications every day. So this one, we see it all the time. But however, if the patient stops taking the medication for some reason, within 2 to 4 weeks, the virus comes back as if we didn't do anything. Okay, so that is the key problem with HIV, is that the ART suppresses, but it does not eliminate what we call the viral reservoir. And so I'll go on, what is the viral reservoir? So the viral reservoir is T cells, or what we call resting T cells in the body that harbor the virus. Okay, I'm going to talk a little bit about that. So the problem number one, why we still don't have a cure for HIV, problem number one is that the life cycle favors HIV persistence. So this is the simplified life cycle of the virus, where the virus enters, uncoats, reverse transcribe, and then it integrates into the genome of the person's T cells and macrophages. So this is where the problem is, right? Now, so it becomes part of the person's, if you like, DNA, basically. And then it doesn't go for simple cells, it goes for the T cells. And for those of you who are not immunology educated, so the T cells, these T cells are the cells that if you get an infection, let's say you get the flu or COVID or something, the body produces these T cells that comes to fight it. But then after that infection is over, there's a portion of the T cells that go into the resting state. And they live in your body for the rest of your life. So when next time you get the same infection, those ones come quicker and come and fight it. So the subsequent infections are milder. So it turns out that HIV infects these cells. So the cells that are being engineered to live in your body forever are the T cells that HIV is also inserted in. So whilst you are on ART, the virus is not replicating. Because the virus is not actively dividing, the ART does not touch the cells in the reservoir. But if you stop taking the ART, then it's able to produce more virus, and then you can get sick again. And the problem number 2, I think I just talked about that, is that these cells are long-lived. So we have, I'm talking about memory T cells of different types, monocyte macrophages in the brain and other places. You have lymphoid-associated tissues, and these cells are quiescent, which means that under normal circumstances, they are just quiet, minding their own business until the right infection comes. So that is really the huge problem. And then one would say that, okay, what if you are giving them ART, why doesn't, over time, the reservoir, disappear? So they've done studies on this where you follow patients who are on ART, you measure the DNA in their PBMCs or peripheral blood mononuclear cells to look at how the reservoir decays over time, okay? So the DNA assay is what you use to measure the reservoir. And here they did it for about 200 weeks on the same patients, following them. As you can see, if you take a particular patient and you follow, it's pretty stable over time. What has been modeled in mathematical models is that if you are just going to use ART, it will take 70 years for the virus to disappear from the person. So as you can imagine, exactly, but then you are dead from something else. Okay, so ART is not a viable option, okay. Now there are new ARTs that you can take, once every 3 months. So there are now injections that you can take once every 3 months. They are not in Ghana yet, but those are going to at least help a lot in bringing compliance for patients. And there are even clinical trials now for medicines that, if they work, you take them twice a year. You get an injection twice a year, and that's it. Okay, so all those developments are coming. So we hope they come so that we can stop our cure research. But if they don't come, then you have to keep working. So about 10 years ago, there were glimpses of hope for cure. Because at some point, people gave up, or people were not really talking about cure. But then Timothy Brown got cured of HIV through a stem cell transplant. So he had HIV, he had leukemia, and then he needed a stem cell transplant. So they took the stem cells so the stem cell transplant is a very gruesome procedure where it's very crude, where doctors will blast your whole body with radiation to kill all of your bone marrow cells, and then give you cells from a different person. And then with the help of immunosuppression, when those cells take in your bone marrow, now you have new type of cells, right? So that's the process. A lot of patients die in the process anyways. But, if you have leukemia, you have leukemia. If you don't do it, you're going to die anyway. So, somebody said doctors there. All right. So what they did was that the doctors were very smart, and they used what you call delta 32 mutation stem cells. So there are people in Europe, about 1 to 2% of people in Europe of European origin, they have this mutation on their CCR5, which is the receptor that the virus needs to establish the initial infection. And if you have this delta 32 mutation, you cannot get HIV. So there are people like that who can get HIV. So, but unfortunately, those of us in Africa, we don't have that mutation. So they look for somebody with a delta 32 mutation and then give Timothy this transplant. And for the longest time that he was alive, he we can show his face here because he was an activist for HIV cure. And he subjected his body to all kinds of tests, like for them to do biopsies on his intestine, do biopsies on his, cerebrospinal fluid, do biopsies on his lymph nodes, everything that scientists wanted to do with him, he agreed for them to do. He died recently last year from complications of leukemia, not from HIV. But this brought a lot of hope. And then there was a Mississippi baby who was a child, whose mother didn't go to antenatal, and in Mississippi in the US. It's not really in Ghana that people don't go to antenatal. Mississippi is, I think, the poorest state in the US, and a lot of these things happen there. So this woman went in for delivery, and they realized that she had HIV. And so they did a delivery, did all that they had to do. And then they started treating the child with an unusual high-potency regimen. The child was positive for HIV. Anyway, so then the mother disappeared for 18 months with the baby without any treatment and then came back. When she came back, she had not given any medication to the child. But when they tested, they couldn't detect the virus. Okay, so that was very encouraging that if you start treatment very early, maybe you might be able to cure it. So they kept following the baby, but then after some weeks, after about 40 weeks, 40 months of age, the virus came back. Okay, so then she had to go on treatment again. But this all shows that the viral reservoir can be controlled at some point, right, if you did the right thing. So that is what has spurred a lot of energy in HIV cure research. And now many organizations like the NIH, HIV cure is one of their big priorities. So how will a cure look like? So I'm sure somebody's like, well, if you're saying cure, then cure means no virus. But for HIV, that's not how we think about it. We think about it in 2 or 3 terms. The first term is like what you call eradication cure, where like you remove all the virus from the body of the person. We used to call it sterilizing cure, and then they said it was not politically correct. So now we don't call it that anymore. So we call it eradication cure. And then there's what you call functional cure, where like you reduce the size of the reservoir so much that if you stop treatment, the virus will not come back, right? So that is what most of us think will at least come on board first before a full eradication cure. So what are some of the HIV cure strategies that we are pursuing? And we are doing all of these at Noguchi now. So so if you want to join us, come and join us. All right, so the first is what we call shock and kill approach. This is the most studied approach. So the idea here is that you have a patient who is on ART, right? So they are on ART, their virus is undetectable, but then they have these, T cells in their body which are dormant, right? So the idea here is you go in with another agent that will go and stimulate those T cells to produce the virus agents. So these are compounds that go in to reverse the latency, and you can now see like HIV RNA in the blood and everything, So these things do work. So far, there have been a number of phase 2 trials. All of them have been, well, maybe I shouldn't say disappointing, but they have not been able to reduce the size of the reservoir, right? But you can see the RNA in the blood, which means that in principle, it could work, right? So that is, a lot of people are working to look at, okay, if you reactivate the virus, maybe you need another agent to actually kill them rather than depending on the immune system. Because people with HIV, their immune system is already compromised. So maybe you need killing agents. Maybe you need better reactivation agents that can reactivate most of the latent reservoir. So those are some of the things that we are working on. And then there is the second approach that we call block and lock. It's almost opposite to the shock and kill. The idea is that what if you could like get into where the virus is inserted, right? Modify the chromatin such that even if you stop medication, the virus will not be able to replicate. Okay, so the idea sounds kind of crazy, but it's not as crazy as you think, So like, if you look at the human genome, about 8% of the human genome is made up of retroviruses. Did you know that? Yeah, about 8% of your genome is viruses that we have acquired, in evolution over time. Okay, so, and some of these viruses, scientists can take them out of the genome and replicate them in the laboratory. But if they are like in the cells where they are in the human body, they cannot replicate because of the modifications around, the chromatin, the epigenetic modifications. Okay, so this is the other idea that we are working on that as well, and I've published a few papers I'll show you on that. This is a new idea, so there have been some moderately effective mouse studies so far. And then there's the gene therapy, right? This is the most sexy of all the approaches, right? So, so what if you could go in, now we have CRISPR, right? We have talents, we have all kinds, zinc fingers, all kinds of ways that you can go in and excise DNA from the genome. So what if you could go in, just excise the HIV, take it out, and then case closed, right? So that is, the problem is that in the lab, we can do this. So in the lab, you can, in the cell culture, you can do it and it works very well. But in people, the problem is how to get these CRISPR and things into the cells because they are bulky and they are not that easy to transport into the cells. So a lot of people are working on ways to make it easier to get access to the cell. Okay, the latest one was a trial done actually at Washington University. That is the only gene therapy human trial so far using CRISPR-Cas9, where they gave the people CRISPR-Cas9 and they were not able to reduce the reservoir. So it didn't work, but they think that is because the dose that they gave was too small. It was done by one of my colleagues. So we will see how this goes. What I can say is that some of the cell culture studies, long-term culture studies have shown that the virus can even develop resistance to the CRISPR. So it's not all, easy stuff. And then there is the immunological approaches where people make monoclonal antibodies against the virus. So you can use like shock and kill and add monoclonal antibodies to kill the cells that are, producing the virus. This, I think, is probably the most promising approach in the short to medium term. So the approaches that are being used, for those of us in Africa, we need to always consider ourselves, right? Somebody met me at a meeting and he said, because of some of the things that we've been writing in the literature, he said, are you the guy who is trying to democratize HIV cure research in Africa? And I said, yes, I'm the guy. So, so like shock and kill and block and lock is the risk is quite medium, right? Because you are just adding another medication to what they are already receiving, right? Something like gene manipulations, like the gene therapy where you are going to excise the virus. After you excise the chromatin, right, you don't know what is going to come together. And whether what is going to come together is going to produce oncogenes and produce cancer or whatever, right? So the risks are pretty pretty high. As for stem cell transplant, don't even talk about it. That is not a viable way. It's just a proof of principle that you can get a cure. And then the immune-based therapies, we think, so these are the ones that we think can be easily applied in Africa, right? So Chris wrote a review on that HIV cure methods, which ones are appropriate for Africa, okay, which was published in the 9th journal. So I'm talking about cure research, right? So for us at Noguchi, our aim is not only for Ghana. What we want to do is to make sure that cure research is being done first in West Africa, and then, because West Africa actually is the most challenging because like I said, our viruses are the most difficult to deal with. If you take a look at the literature on cure, very little of it is being done in Africa, unfortunately. Okay, so why should we do cure research in Africa? I think from what I've been saying so far, I don't need to give you the reasons, right? So, but I'll give you anyway. So, of course, we have 70% of the people living with HIV, right? And most of those who are not on medication, who are still suffering, are in Africa. So we should take it, more serious than anybody else. We also have co-infections, HIV-2. We have what we call persistent low-level viremia. Let me explain that a little bit because it's one of my pet annoyances, so I have to talk about it. So in the developed countries, right, if somebody is on ART, the threshold to say that your virus is controlled is that your viral load should be less than 20 copies per mil or less than 50 copies per mil, right? In Africa, the WHO says it should be less than 1,000 copies per mil. So what that means is that when in Ghana we say these are the number of people whose virus is controlled, we are not counting at undetectable. We are counting at less than 1,000. Okay? But between 200 and 1,000, it has been shown that the virus can actually develop resistance. Okay, so you have people who the doctor sees, oh, you are less than 1,000, go home. Okay, and then a year later, that same person will develop resistant viruses. Now, the reason the WHO made that recommendation is that if you are less than 1,000, the probability of transmission is very low. It's almost zero. Okay, so they based it on epidemiological and transmission things, but they didn't base it on like resistant development. Okay. The latest guideline, we're hoping they will change it, but then they still didn't. But a lot of people are now clamoring for them to change that. So Dr. Boni is working on looking at persistent low-level viremia and resistant development. We are hoping that we will get results that will make the WHO change their mind. Of course, like I said, we have a lot of subtypes, and then we have a lot of the cure strategies who ask patients to make a lot of sacrifices, okay, like in the clinical trials. And you don't know whether these are going to work or not, right? So it's like you don't know whether they will be beneficial, but then you're asking people to make a lot of sacrifices. And will patients even be willing? Because like if I'm taking my ART once a day and my virus is controlled, I'm going about my normal life. Why will I be involved in a trial that may kill me and will not, give me, and I don't know whether it's going to be beneficial, right? So all those questions need to be asked. So all those are things that we need to talk about. And I'll show a little bit of data. So what we did was that, when you go to meetings, everybody say, oh, cure research is not happening in Africa. Research is not happening in Africa, but nobody has data. There's no data. Okay, it's all anecdotal. So we decided to put some numbers to this because if we have numbers, now we can argue, okay? And I can say that since we started doing this study, I think we've gotten 2 or 3 grants because of the data we generated from this. Okay, so what we did was that we did a review of all the cure-related literature that have been published from 2010 to 2022. And then after we did all of our exclusions, so we excluded things like, commentaries, review papers. We wanted like original science, scientific papers. They could be epidemiological, they could be basic science, they could be animal studies, they could be clinical trials. When we finished, we had 1,077 publications that qualified for. And then the massive action team went through each paper to identify where the research was done, who were the authors, where the authors came from, and who funded the studies. Okay? That is what we found. So we found that HIV cure research has been exploding over the years, right? As you can see, between 2010 and 2022, there was a tenfold increase in the number of publications on HIV cure. So where were the studies being done? So this is where the studies were being done. So this is study performance side, is Oct continental affiliations. So most are in the US. So out of the 1077 papers, as you can see, about 600 and about 700 were from the US. And then Europe, and then Asia, mostly China and Japan. And then Australia. And Australia, is fully about 30 million people. They are doing a lot more than Africa with 1 billion. 1 billion people. So out of the 1077 studies, 31 were done in Africa over that 10 years. Okay, so that is very, very, very low. I mean, we're expecting it to be low, but not this low. Okay, and then the ones done in Africa, mostly was done in South Africa. And then East, and then West, a little bit. So there were 4 papers, and I think most of them were from us. So okay, so none in Central, none in North. North does not really have a big HIV problem, but Central they do, but they're also not doing much. And then we look at where the funding is coming from. Of course, it's mostly NIH funding, and then European governments and agencies, Asian government and agencies. And then the studies that were being done in Africa, the few studies, a lot of them, most of them were funded by the NIH. 27, yeah. Were funded by the NIH. Okay, so, and then we realized that Wellcome Trust and EDCTP have not caught on to the HIV cure thing yet. I hope they catch on soon so that we can apply for some. We've done a number of applications that have been rejected from them, so it's not their priority yet. Anyway, so this is what we found. So this shows that we really need to do something, right? We really need to do something because this disease affects us. You see, what this means is that because the studies are all done in Europe and the US, they are all on subtype B. Okay, and then the subtype that is in Ghana, that is in West Africa, that is in Africa, are completely neglected. Okay, so this is really urgent. In terms of the type of studies, most of it were basic science, but the African studies, so ex vivo is when like you take blood from patients, HIV patients, and then you work on them in the lab. There were 0 animal studies in Africa. Most of the studies in Africa a lot of them were epi studies and ex vivo studies, few basic science, 2 clinical trials. So very little, that is the bottom line. So I think that is where our program HCRIS comes in. It stands for the HIV Cure Research Infrastructure Studies. This is our logo, massive action. So it's a joint effort. So when I came in 2018, what we did was we sent a technician to go to WashU to spend 3-4 months to learn some of the basic cure stuff. And then subsequently, we've had a student and a postdoc also go to learn. And then, of course, Noguchi was very generous with all the lab space and the equipment. And then in 2019, because of these resources, I was able to get the EDCTP Senior Fellowship grant to start the program. So since then, so our vision is to make Noguchi, if you like, the Center for HIV Cure Research in Africa, right? So where if you say that, oh, you want to do HIV cure, you go to Noguchi. That is our ultimate goal, but as you know, it takes a while. So the plan is to train a lot of people who have their own cure research portfolios, and then over time, you know, the place will become known for it. So for the initial grant that we sent to the EDCTP, our aim was to form a cohort of HIV patients that we can follow. Now, the problem with cure research is that you need people whose virus is, most of the time, whose virus is undetectable. And in Ghana, what happens is that checking the viral load for the patients is very sporadic. So you don't know who is suppressed and who is not. In the US, when I want to do this kind of research, I just go to the clinic, I look at the list, I see who is suppressed, and then we call them. But here, it's not that easy. So what we had to form our own cohort. So we form our cohort of about 390 people that we've been following over the past 4 years or so. And so we know who is suppressed, who has persistent low-level viremia, who is not suppressed, and so on. And then the next one was to screen 150 epigenetic compounds and African herbal extracts to see whether they can reactivate the virus from latency using the shock and kill approach. And then we were also wanted to do a biobank and also train people. So we have done all of this, and as you can see in our cohort, when we follow them, there's high rate of suppression. So about, if you look at viral load as less than 1,000, then, you know, this is the number that we have that are suppressed. If we go to, so less than 1,000, then this. If we go less than 50 copies, it's much lower. We have maybe about 80 or so patients that are within that persistent low-level viremia range. The other thing we did was to, what Anthony did was to measure the reservoir size for the people who were in the WHO controlled range of, let's say, 50 to 1,000, and then those who are in the developed country control range of less than 50. And if you look at their reservoir size, the reservoir size is 3 times for those who have the persistent low-level viremia. Now, the implication for this is that if your reservoir size is that huge, right, getting rid of it when a cure comes will be very difficult, okay? So that is why we need to change that policy. So another thing Evelyn and Helena did was to look at what Ghanaian patients think about HIV cure research. What kind of risks are they willing to take? So this is, when we ask them what kind of procedures they will be wanting to involve in, a lot of patients said, almost everybody said they will be willing to do questionnaires and blood draws, right? Adding more drugs, you know, like the shock and kill or the block and lock. Pheresis is like where you hook a cannula to the person's blood. It's like doing dialysis, where like you take a lot of white blood cells from the patient. It's a long procedure, it takes about 3-4 hours. In the US, we do that a lot because you need a lot of WBCs for these studies. When it comes to blood donation, most patients say they are willing to donate less than a quarter pint. You know, a pint is like what you donate when you go to do blood donation. Okay, so that is about less than 500 mils. So you can see that they are very risk averse, you know. And then another thing that we usually do in HIV cure research is what we call analytical treatment interruption, where like you give the person something that you think is going to cure, and then you ask them to stop ART so that you follow them over time. Usually you follow them closely, maybe every 2 weeks you measure the viral load. If it goes up, you restart their medication. When we asked patients in Ghana if they were willing to do that, about 67% said no way, right? And even the rest said like maybe, you know. The yes, we got only 13%. Now, if you look at studies that have been done in Europe and the US, it's the exact opposite. 67%, 70% says yes, they will do it. Okay, so our patients are more risk averse than people elsewhere. And this is why some of these studies need to be done here, right, so that we know what we are dealing with. Because you may get a clinical trial for cure and nobody may be interested in it. Okay. So this is what some of the patients said. Somebody said, 2 friends of mine have passed on 9 months because they stopped taking their medication and went on the so-called cure. You know, there's a lot of herbalists and things that say they have cure. So patients have seen some of these things over the years, right? And so if anybody comes, whether you're a herbalist or you're a professor, you know, they don't want to hear it. And then one said, the boundary will be if they ask me to stop taking my medication. I will need serious counseling on that. Okay, so this is we don't know why they have these views. You know, we need to do more social science studies to figure those things out. And then we've done some shock and kill studies as well. Am I doing on time? Okay, I have to speed up. We've done a number of shock and kill studies. In this study, we screened compounds, new compounds, what we call histone deacetylase inhibitors. What we do is that we can do this in a cell culture system. So we have the HIV that we put GFP in, and then we have it in latency in these cells. It has been engineered for latency. So if we add a compound and the virus, you know, comes out, then we know that it's a good latency reversing agent. So the more GFP you have, the better the compound. So as you can see here, all of these are published. And then recently we published the first model to study HIV latency in macrophages. So this is the first one in the world. So we hope that it will help, you know, people to also study macrophages because they are also an important part of the reservoir. And then Christopher, for his PhD, screened 150 compounds and some African herbal extracts, identified some of them that are good reactivation agents. So out of the 150, he got only 1, 2, 3, 4, 5. No, he got about 5. Yeah. So as you can see, you know, so some of the things we want to do is to be able to do high throughput screening. That way, you know, you can screen a whole library of compounds and then see what you get out of it. So he confirmed this in primary cells and also in patient cells. So these are patients who are on ART, whose virus is undetectable. And then you get T cells from them, you stimulate them in the lab, and you see what you get. And then for the block and lock, we identified this protein called SL3B1 that is able to, when we block it, we are able to block HIV from coming out of latency. Okay, so we are able to completely stop the virus from coming out of latency. So that is another one that we are currently working on. So those shown here used to be postdocs. They are not postdocs anymore. Now they are supposed to do their own research. Some of them want to be postdocs forever, but yeah. So Evelyn is working on persistent low-level viremia, for which he has an NIH grant for, and also other grants. And then Helena got the ADC Preparatory Fellowship, went to Amsterdam and WashU, and working on FC gamma and co-infections. And James working on cancer comorbidities. And then Ecole who is at UCC, is doing HIV pharmacogenomics. So we have done a lot already in training people, which we are very proud of. And this is a table of some of our achievements, a lot of students, a lot of grants, because in HCRIS, if you are a student or a postdoc, you are mandated to write a grant. So you can't just be there. You have to write and send grants and compete in the open market to support your research. So that, we believe, has helped a lot. And of course, we have a bunch of abstracts and papers. I think these are all dated. There should be more by now. So yeah, so some of the things we are doing, we are still screening a bunch of African herbal extracts for the shock and kill and the block and lock approach. Prof. Regina has been helping us with some of the extracts. We also have some of them from Mampong that we are working on. I talked about this already. We are looking at how HIV, co-infection with TB and hepatitis and malaria and so on affect the reservoir. These are studies that can only be done in Africa, right? You can't do those studies in the US or anywhere else. And then comorbidities like cancer and so on. What are our future plans? So our future plans is to get money to expand the HCRIS cohort across the country, have children and adolescent cohorts as well. The cohort we have now is all adults. Develop tools for reservoir measurements in West Africa. We've sent a couple of grants on this, which we didn't get, but that did not stop us from sending more. So we just sent another one that we hope we will get. And then see the impact of the different variants in West Africa on the reservoir, including the HIV too. And then form a West African collaborative. So we are working with a lot of colleagues some colleagues in Nigeria, Burkina, Mali, and so on, to try and form this consortium. And position ourselves as a site for HIV cure trials in Africa. So we need to acquire the necessary machines. So I'm glad Director is getting us some cell sorters because for, can you clap for her so that she will? So that she will speed up the procurement. But she's getting us those. So those are very important because, you know, the HIV, we have different types of resting T cells, and often we need to like sort for different types. That's something we can't do here because there's no cell sorter in Ghana. Okay, so we are getting one at Noguchi and we are very proud. We are hoping to get a digital droplet PCR machine. That couldn't make it to director's list, but we hope it will make it on the list in the future. And then we are going to, we have written some grants to see if we can buy those with those grants. And then, of course, we don't want to do something that, you know, when I retire in next year, then it's gone, right? So we need we need sustainability, right? To do that, you need to train people. So that is why we got interested in the Fogati D43 training grant. So through Washington University, we were able to get a grant. Thank Director for her awesome letters of support. So this is a grant that will help us to build capacity for HIV cure research at the University of Ghana. Okay, so it's only for Ghanaians. So, and then to equip trainees with 2-year intensive mentored postdoctoral research projects focused on HIV cure. So when we say intensive, we mean intensive. Okay, so this is the massive action group. Sometimes we can go 48 hours straight submitting the grant, okay, without sleep. Okay, I think that's our record, right? 48 hours straight. So, and then maintain a mentorship plan. It will train, the original grant was to train 3 PhDs, 4 MPhils, and 4 postdoctoral fellows. But they announced some supplements, and, you know, for us, one of our mantra is always say yes. So any opportunity that comes, say yes. Okay, so I'm not talking about massive action today, so let me not digress. But anyway, we applied for both supplements, and then we got both of them. So now we can train 6 more people. So now, instead of 11, it's going to be 17 people. So in 5 years, we'll have at least a good number of people who can do these things and who are competent to write their own grants here at Noguchi. So what are some of the lessons learned? So people often ask me, why did you go back to Ghana? You know, your lab was doing very well at WashU. But I always say that this is our country. Nobody will build it for us. We all have to pitch in to do what we can to help. So institutional support is key. So we have strong support from director, which I think helps us a lot. Writing last-minute letters and things like that is very, very important. And also from Washington University. Be patient. Things go very slow in Ghana, which is my chief frustration. But maybe God knows I need patience, so He's teaching me. And then good mentorship yields results. So if you mentor the younger ones, things are going to happen. The challenges are, of course, the slow pace of basic science research in Ghana. And it's not because of, our people here are smart or smarter, but the problem is the logistics, right? So, I mean, if somebody sitting at the lab at Washington University, if they have an idea, they order something, in 2-3 days, it's there, they are doing their work. Here, you have an idea, you order something, 3 months, you are still waiting. Okay, so how can you compete? So those are things that we need to solve to make science enjoyable for us. So our next step is to expand our cohort, develop the tools. I think I've talked about all of these. Have the high-end equipment, and then position ourselves here at Noguchi as the site to go and do HIV cure research. So my conclusions are that HIV cure research is advancing at a rapid pace. As you can see, 10 times the number of publications within 10 years. So that is a very rapid pace. The approaches to cure include the shock and kill, block and lodge, gene therapy, and immunological methods. Almost all the cure research so far is focused on one subtype, which is not our subtype. So it means that we have to African scientists must step up so that African patients can be included in cure research. Our aim is to make Noguchi the go-to place in Africa for cure research. So to achieve these goals, we believe that training and mentorship is key and is the way to go. So with that, I want to thank the team, the Massive Action team. Have a lot of pictures. So they all work very hard, and we couldn't have done all of this work without your ability to work at night and to work, at ungodly hours. And then some of my collaborators, and I want to thank my colleagues in biology, my former HOD, current HOD, for all of your support over the years, and all of these funders that have supported us. So, thank you.
We can do better. Let's do it better. This is very, very educative. Very, very. I realize we've been sitting for some time now. Before we take the questions, can we be on our feet and then stretch for a while? Yes. Okay, we can sit now. So we open the floor for questions. Questions, contributions. You can see. Okay. Professor Makusi first, and then Miriam. Can we have somebody to pass the mic around?
Prof. J, thank you very much. I think you all agree once again we didn't make a mistake selecting Prof. J to be one of the lecturers. It's been an exciting one. Thank you very much for that. So just to give you some information before I come to my questions. So the cell sorter you mentioned arrives in Ghana today. And hopefully it will be cleared, and then for the rest of October will be installed and people trained on it. So we are on the right course. Thank you very much, Director, for that. So I have two questions. The first one is about the gene, one of the cure examples, gene therapy, yes. I'm just wondering practically how that works, because these are a lot of cells that would be harboring these latent forms. So how, when you say you are pulling those cells out, or when you say you are cutting out the viruses, I'm wondering exactly how practically it would work, because you have a number of cells probably distributed throughout the body. So exactly how would that work? The second question is about West Africa. You mentioned HIV to being more or less limited to West Africa. And we have other diseases like Lassa fever, TB, there is an example. What is it about West Africa that we are attracting all the bad stuff? Is this something we are doing or something in our environment?
Well, question I will be saying. For the first question, so theoretically, it will actually be good. So like if you have a way to get the Cas9 into the cell, right? What happens is that if the Cas9 goes into a T cell and the T cell does not have the HIV, it will not have a target, it will not bind, and it will get degraded. But if it has a target, then it will bind and do its job and get degraded. So in theory, if you could get those enzymes into the cell, so what will happen is that it will go into most cells, but where there is no target, then it's so that is how it's going to work. As to why West Africa has a lot of diseases, I always say maybe we are the most involved, you know. So we've been here for a long time. We've been here for a long time. We've lived with, you know, the animals here for a long time. We've acquired their diseases, and you know we have evolved, you know, more than probably most other places. So that is my theory. Yeah, but I don't have an answer to the question.
Thank you, Prof. Che, for this insightful presentation. I want to find out, you said for West Africa we have a lot of subtypes. So for the patients you are working on, you are able to probably sequence to know the kind of subtypes, and then which of the extracts to be able to, I want to know if you were able to do that, work effectively for that. My second one is not a question. I think the research that was done on the human perception on the HIV cure, I believe that in our setting, people are not so, they can't trust the setting, because when they go through those processes, how the measures that have to be put in place to restore them or restore their health is a problem. So I think that's one thing we have to look at in this setting. Thank you.
Yeah, I agree with you. So for the subtypes, what we are doing for our 390 cohort is to subtype each and every one of them, and then also measure the reservoir for each and every one of them. So that is where that is ongoing. We are maybe a quarter or halfway through that work. What that will do is that it will enable us to know which subtype and who can be called for which study. So that is something that we are currently actively working on. Yes.
Thank you, Prof. Che. I also have a question regarding the subtype. So you mentioned that in West Africa we have a lot. So what I'm curious about what's the situation in Southern Africa and then also East Africa where the burden is high. And then my other question too is regarding the shocking of the T cells and destroying them. It's an ignorant question. What happens to the DNA when the cell is destroyed? Thank you.
Okay, so for starting from the second question, so for when you do the shock and kill, basically the cell undergoes apoptosis, so which is a process that cells undergo all the time. So when the cell undergoes apoptosis, of course the DNA is released, but because it's open DNA, then it is destroyed. Your first question again? Oh yes. So fortunately for them, they have almost monolithic subtypes. So Southern Africa has subtype C, and Eastern Africa has subtype D with some subtype B. It's mainly when you start coming west, you get to DR Congo and Central African Republic and Cameroon and all the way to Senegal. That is where the combination subtypes are. Yeah, we have the more interesting ones.
Okay. Thank you very much, Prof, for your very insightful presentation. There was a lot I didn't know about HIV, especially the subtype issue. So it's very interesting to know all that. Thank you for the education. I have 3 questions. The first one is, although when it comes to ARTs, you mentioned the fact that there's an example where a single pill per day is taken by the patients. I want to find out if you have data on patient compliance, because whether it's one or, we are all human, we may miss doses or at one point or the other. So do you have data on that and how that affects maybe poor performance with the 95 target? That's the first question. The second one is you presented a data, some data in a table where for animal studies it was 0. So I want to find out if Noguchi, how is the story of Noguchi in that direction? Do we have the capacity to take up that role and fill the gap there? And then the last one is maybe a crazy question, but the issue of the getting the Cas9 in the cells, has there been consideration for nanotechnology? I mean, I'm just being ignorant in that.
Yeah, that's not a crazy question, actually. That's brilliant. So, yes, so people have used nanoparticles to deliver the Cas9. And people are working on different types of nanotechnology to try to do that. So, yeah, that is actually being done. In terms of compliance, there is a lot of data showing that when you move the pills to multiple pills a day to like 1 pill a day, the compliance goes through the roof, like it increases a lot. I think for us, most of our problem, what is known that a lot of patients are actually pretty compliant. Studies that have been done in other places in Ghana, up to 80-90% of patients take their medications. Our problem is that we are not able to monitor them as we should, right? Because like if I'm taking my medication and the virus is resistant and you are not checking the viral load, you are not checking the resistant, you will know. So that is where our issue is. And your third question? No, I answered the nanotech one. Animal capacity, yes. Yes, so fortunately Noguchi has an animal facility. So if anybody can do it, it is us. So we have an animal facility. There's a lot of the cure studies are now being done in mouse studies because the monkeys are too expensive. And for the mouse, you can use humanized. We use humanized mice to do that. One of our collaborators has a number of interesting humanized mice. So yes, so if you want to do it, all you have to do is to import the mice. Or even have some of our people go and learn how to do those, how to do the genetics, and to be able to support those kinds of services. So yes, potentially we can do it here.
Thank you very much, Prof. Chi. This has been a lecture from HIV 101 to 707. So my question, since I'm starting from 101, is still about the subtypes. How are the viruses evolving? I'm interested in the evolution of these subtypes, such that the global West should be interested in the West African subtypes, because probably it's just a matter of time and it's going to spread. I don't know. Educate us on.
Yeah, that's a very good question.
Drug discovery.
Yeah, so there's a slide that Evelyn has that I didn't show. Like when they started detecting HIV here at Noguchi, initially it was HIV-2 mainly. And then over time, HIV-1 took over because HIV-1 is more aggressive. And then now HIV-2 is very minimized, really difficult to find patients who have just HIV-2. And then we have those with HIV and HIV-2. Nobody is aggressively studying this, but we are going to make efforts. We have two upcoming postdocs here who are going to be working on that, because if, let's say, for the patients with HIV-1 and 2, there's potential for them to have like recombinations, and before you know, they will form a new virus that nobody can control, right? So that is something that we are interested in. And then the subtype evolution, the subtype that is most common in West Africa in general is called the CRF02AG, which is a combination between subtype A and G. And that is what traditionally has been detected in Ghana. The subtyping we are doing now, we are seeing a lot of B subtypes, which we haven't finished, so I can't say too much, but it could be that, a lot of subtype B is being imported into the country from Europe, and the AG is not likely to evolve to become B. So most likely what is happening is that with, Panafest and everything, and years of return and everything, HIV subtype B is also being returned into the country. So we are seeing that, but it may be an Accra problem, right? It may be an Accra issue because a lot of the tourists and so on will probably be in Accra, but maybe if you go to Koforidua or Tamale or something, it might be different. So that is why we want to have spots all around the country to be able to do some of this work.
Hello. Thank you so much for your talk. It was very insightful. I have two questions. I think the first one is, you mentioned like an immunological type cure, and you mentioned monoclonal antibodies. Is there any type of research on what type of antibody construct it will be and how it will actually work? I think my second question is on the human perspective aspect. Is there anything in your framework that centers around science communication so that we can kind of give the Ghanaian public the full picture before they commit to something like that? Yeah, thank you.
Yeah. So the immunology. So people are making a lot of what we call broadly neutralizing antibodies. So the broadly neutralizing antibodies are antibodies that often you isolate it from a patient, and then it is so broad that it's able to, if you like, bind to different virus subtypes. So if you're able to ask, so what we find, all the studies have shown is that often one BNAP is not good enough, and you need a combination BNAP. So most of the BNAPs, there some are for the HIV GP 120, which is the viral envelope. Some are also targeted against the CD4. So there are different types of them. And now what people are doing, which we haven't done here yet, is you can isolate the antibodies straight from the B cells using next generation sequencing and other techniques, so that instead of doing trial and error with serum and all of that, they get it straight from the B cells. So we want to get there. Now that we are having a cell sorter, we can easily do that. So those are things that need to be done. In terms of the science communication, that is always an issue. Right now, when a cure hasn't come, it's hard to go and educate people about cure. So what we could do is to do it among our cohort, to educate our cohort, because those are the ones that we're going to use, we're going to call on for the study.
Yeah, Prof, thank you so much. I know I could bring this to your office and we discuss, but let me just ask quickly. So SF3BP1, you inhibited it pharmacologically, and then you saw that you were able to block the latency, right? Like the reversal of the latency. How about overexpressing SF3 or using a molecular maybe agonist to increase the expression of SF3BP1? What will happen? I'm thinking about the shock and kill so that maybe it can be employed. Is there a possibility?
Yeah, it's definitely a possibility. We haven't explored that angle because so first of all, SF3B1 is it's a very important protein in the cell, and it's needed for splicing, generalized splicing. So if you increase the amount, you're going to cause a lot of problems. So what we actually, and I didn't show all of that data, but what we have done now is that we have isolated the tiny portion of it that is important to bind to HIV TAT. And then we are using those tiny portions to develop a drug screen to inhibit HIV transcription. So that is the approach we've taken. We've had a lot of issues with reviewers for grant applications because of the importance of the protein. So our approach is to go for that specific part that hopefully will not affect the cellular processes that the protein is involved in.
Thank you. So my first question is on the subtypes. Because we have most subtypes, but within our region also, we know access to interventions and to ART is also very, very low. Could that be one of the reasons why we see a lot of, or does that enhance recombination of the virus? Has anybody looked at it? And then my second question is actually your perspective on the use of broadly neutralizing antibodies. In terms of our region and also for other LMICs, do you think the use of antibodies would be cost effective for us as a therapeutic intervention? Thank you.
So the subtypes, we believe, is because the virus has probably been evolving in West Africa for a very long time before it jumped into humans, right? So like, actually HIV-2 is a precursor to HIV-1. So HIV-2 evolutionary has been there for a long time before HIV-1 kind of twisted itself and came out of it. And then that became more pathogenic. So I think the subtypes and the combinations have been there. But it's also possible that it could be fueled by non-treatment. Obviously, if you are not treating and people are, getting different subtypes, then mixing can go on. But usually these mixings are not, it's not like, a 5-year thing. It usually takes a long time. So that's why I believe probably these have been going on in those, in other primates for a long time before they came to us. In terms of the broadly neutralizing antibodies, what was the question again? Cost effectiveness, yeah. So usually when you are doing these things, you don't talk about the cost first, because if you talk about the cost, you will never get it done, right? Because there's enough money in the world, there's always a way to pay for something, right? So you do it, if it works, somebody will pay for it, right? It's like ART, at first they said, when they were bringing they were broadening ART in Africa, they had two issues. They said it's too expensive, and then second, they said that, oh, we don't have enough doctors and others in Africa to supervise it and all those, you know. I don't want to use some words, but anyway, what happened was that actually people in Africa are more compliant, and you don't need a doctor with 1,000 degrees to follow, you know, a patient. So long as the patient is taking the medication, most of these patients are fine. So actually, if you go to the southern and eastern belt of Africa, most of them are nearing the 95, because they have like decentralized the thing. Nurses supervise this. You know, is pretty. If you have the infrastructure to measure the virus and, you know, do viral loads and things like that, and you teach, you know, nurses and community health workers to interpret it, it will work. So yes, now if you develop a monoclonal antibody, it might be a little expensive, but if it's something that works, you know, nobody knew that PEPFAR, you know, former President Bush in the US will make a law for PEPFAR that has been going for almost 20 years now, that has saved about millions upon millions of lives, right? So.
Thank you so much, Prof, for that exceptionally informative talk. I just had a question about a few earlier slides ago about the HTLV co-infections. Just being a cousin of HIV, whether there's any information being captured in the community when they measure HIV, whether they also capture HTLV, and more specifically, whether your group will be tracking HTLV1 infections.
I think the work that was done here, when they did co-infections, it was like 1 to 2%. Yeah, it was pretty low. That was done by Chris Enko here. HTLV, the place that is most popular is Japan. Because it causes the T-cell leukemia, which can be very devastating. So that is where it is most studied. It's not being studied that well in our setting, but it's definitely here. But no, we don't try to detect it when we are checking for HIV. So it's not one of the things that is tested for in our setting.
As I look at him, I say to myself, this is the scientist who wants to kill the 44-year-old HIV. I've seen a lot of HIV groups here at Noguchi. Prof. AC's team, Dr. Mubarak, Jim Bramford, Professor Ampofo, Evelyn, and the rest. But this particular team, they have energy. Yes, they have energy. And you can see that they will do more. Not that they can do more, but they will do more. They've advertised themselves. Oh, they want more to do more. Oh, yes, I believe. He has said that he wants to make this place, Noguchi, HIV cures center, so that it becomes a center of excellence. The whole of Africa, if you want to do anything with regards to HIV cure, you come to Noguchi. The group is very energetic. And he has also advertised the group. If you want to join them, the door is open. They have more to do. So once again, Prof. Che, I'd like to thank you very much for this lecture. And I would like to thank all of you for coming. I think time is fast spent. If you still have something to discuss or ask, after here, you can still see him, and he will explain it to you. Thank you very much.
Thank you very much. Shall we keep clapping for him? Thank you so much, Prof. Odum, for steering the affairs of this program. I think we've learned a lot. So this virus is a super pandemic. Do you agree with me? Because I checked yesterday, I was asking ChatGTP whether HIV virus is everywhere in all the countries. It said yes. Then I said, are you sure? Usually when you ask certain questions and you ask, are you sure? They say, I'm not sure, check the website. But this one says, I'm sure. It's in every country, so it's a super pandemic. So this morning I asked my sister, is it true what ChatGPT said? She said yes, it's in every country. So I think prevention is better than cure. I hope we all know our HIV status. By faith, I know mine. By faith. So you all agree with me that we've had a very super interesting discussion today, and we've learned a lot. And Prof. Che has branded himself as the massive action professor. No two ways about it. No one can take it from him. And he's also democratized HIV cure in Africa. That's what he's doing now. And I must say that I'm a proud mentee of his mentorship, and it's been good so far. Thank you very much, Prof. Chi. Shall we take note of the following announcements? This October seems to be very interesting with our lectures. Next week, we have a talk on influenza research and impact in Ghana on the 17th of October, and this will be handled by Prof. William K. Ampofu. He's the CEO of the National Vaccine Institute. So please spread the word and invite people to join. 24th October 2024, we have malaria research and impact in Ghana. This talk will be handled by Prof. Koram, Prof. Kwejo Ansa Koram, KAK1, former director of the institute. Please inform others to join as well. 31st October 2024, we have a very insightful talk also from the Ghana Health Service, the impact of Noguchi on the Ghana Health Service Disease Surveillance and Emergency Response System by Dr. Franklin Siedu Bekwe, Director, Public Affairs, Ghana Health Service. This will highlight all the good work we've been doing in Ghana. On the 7th of November, we will have a symposium, panel discussion, and a debate, very interesting debate. Join experts and panelists as they delve into the critical research discussions and debates, the Institute's achievements and future directions. And the 8th of November, we will have an open day. The Institute will open its doors to everyone, especially students, to come and see the interesting work we are doing in the Institute. Thank you all for making it to this day's talk. Please help me invite Reverend Mrs. Eunice Ampem Danso once again to give us a very powerful prayer.
Thank you very much. That was an insightful presentation. God richly bless you. Shall we please close our eyes for a word of prayer? Father, we thank you one more time. We started with you on a good note, and you have ended well with us. We have come back with a thanksgiving. Daddy, Lord, even as we leave this place, we pray that your presence will continue to be with us, continue to be with the researchers, Noguchi, continue to be with our professional health care professionals. We pray that your presence will be with our advocates, O Lord. Continue to give us the strength to do more for you as we are ready to do more. And even as we depart from your presence today, we pray that we will carry along the lessons learned, O Lord, and then the passion that has been ignited, Father, in us, that we will be able to bring a meaningful difference in the sphere of our influence. We pray that your hand will continue to be with our own Father mentors, O Lord, that they will be continue to mentor us well, even in Jesus' mighty name. Thank you for all that you have done, Father, in global health, to be able to impart, Father, our communities and our nations at large. Let your name be praised. Let your name be glorified. In Jesus' name we have prayed with thanksgiving. Amen.
I told you, a very powerful prayer. Thank you very much. Director, on behalf of Director, I want to thank all of you for coming. Have a blessed day.
Thank you.